Okay, so today we will solve this problem. So firstly we will read our problem statement and try to find logic for it, and then we will go and write code for it. So there are n passengers in the bus. Each of them pays separate fare for traveling from A to B. The passengers thought of grouping themselves so that the entire bus group pays the same fare. Thus, bus allows a max group of size k. Find the total amount saved by the passengers if they start grouping themselves. And this is a logic how how the passengers group themselves and pay the money and save the money. If P1 passenger pay F1 fare and P2 passenger pay F2 fare, when these two people make a group, then they pay fare as 2 into minimum of F1 and F2. It means that each passenger will pay the amount of money which is minimum among of them. Thus, total saved amount is the total amount paid by them if they travel individually minus the amount of money if they make a group. Okay, so it means, like, if there are four people in a group, then all of them will pay the amount of money which is minimum among of them. So this group will pay, each of them in this group will pay the amount of money is equals to one, because one is minimum in this case. So two will pay one, three will pay one, four will also pay one. So the total saved amount will be, by the two is one, by the three is two, and by the four is three. So total saved amount is six. Like that, we have to find total saved amount by the entire passengers. So we have given with this array, with this array of passengers. So what we will do is we will sort this array so that it is easy to find that which is minimum and which is maximum. So this is our shorted array, and k equals to 3. It means that we can at max group k passengers in a group. Okay, so if we make our first group, then what will be our logic is that we will try to put the minimum fare passenger in the current situation in our group with the other passenger which has the maximum fare, because if we put the maximum fare passengers in a group which has the minimum fare passengers, in that case we can make maximum profit, or we can save maximum money. So so we have shorted the array, so we can easily take elements from back of the array to take the maximum fare passenger. So the total amount saved by this group is, all of them will pay one amount of money. So 6 will save 5 amount of money. 89, the passenger with 89 fare saved 88 amount of money. So the total amount saved is 93. Now we will make our second group, and we have left with these passengers, because by the other passengers we have made our first group. So now the minimum amount of fare passenger is 2, and the other passenger will be the maximum fare passengers, which will be 6 and 6 in this case. So the total saved amount will be 4 and 4 will be 8. Now we have left with these passengers. Okay, so now we will make our third group. It can be a case that we can left with less than k passengers, then we will put all of them in the group, in our last group. So the minimum amount of passenger will be 3, 4 and 4. The total saved amount will be, by the 4 we will save 1, and by this 4 we will also save 1. So the total saved amount will be 2. So the total saved amount by all the n passengers will be 93 plus 8 plus 2 equals to 100. So now we have made our logic. Now we will go and write code for it. Okay, so now I will write code for our problem. I have already taken the inputs for the problem. In the inputs, the first line n will represent the total number of passengers on the bus, and the next line will be an array which will represent the fare of each passenger, and k will represent the maximum number of passengers that can be grouped in single group. So in the function amount saved, I will write our logic. Initially, we will sort the array as we have discussed in the solution, because after sorting the array, it is easy to find that which is minimum in current situation and which is maximum. And our logic is like, first for the current group we will take one minimum fare passenger and then the other k minus one maximum fare passengers, and then for the next group we will take next minimum fare passenger and then the other k minus one maximum fare passenger, which will be from the back of the array. So I will use two pointer approach, where the first pointer will represent the minimum fare passenger for the current group and j will represent the maximum fare passenger that has not been taken. Okay, so initially the minimum fare passenger will be the first element of the array and the maximum fare passenger will be the last element of the array, which is n minus 1. Okay, so and I will also made a variable as which will represent the number of passengers that has been taken for the current group. So initially it is 1 because we have only taken the minimum fare passenger for the current group and we have to take other k minus 1 passenger from the back of the array. Now we will, for the current j, we will check that if as it means the number of passenger in current group is less than k, it means we have to take more passengers for the current group. So we will take the current j for the current group. So j is decreased by 1 and the size of the group is increased by 1, and the amount saved by the jth passenger is its actual amount minus the amount of minimum fare passenger in the current group, which is the amount of ith passenger. There will be another case where the size of the current group is equals to k. So in that case we will start new group, and so for new group we take we will take next minimum fare passenger, and the size of the group is now for the next group is 1, and we will iterate this array until I is less than j, because if I is less than j it means there are some remaining elements between I and j which is unprocessed or which is not grouped. So if I is greater than j, it means we have taken all the elements from the array and there's zero ungrouped members. Now will print our answer. We have written all the logic here. Now we will run it, and the answer is 103 for this case. Thank you. We will solve this problem statement. The problem statement is like, Sham has n various varieties of dishes lined up in a row where AI signifies the type of the ith dish. He wants to select as many dishes as possible from the menu, but only if the following two requirements are satisfied. He can select only one sort of dish, and the second requirement is two adjacent dishes cannot be selected simultaneously. So there's an array given which will represent the type of the dish, and we can only select one type of dish from the menu. And additionally, the second condition is then we can't pick two adjacent elements from the menu. Now the query is that Shyam wants to know which type of dish he should select so that he has the option of choosing the maximum number of dishes possible. So let's understand this by this example that has been given. Uh, in this menu, if we pick the type 1 dish, then how many dishes we can pick? So if we pick type 1, then we can pick a dish in the index 1, then in the index 4, and then in the index 6, and then if we pick dish in the index 6, then we can't pick in dish in the index 7 because these are adjacent. So we will pick the dish in the index 8, and if we pick dish in the index 8, we can't pick dish in the index 9. So the answer will be 4 if we pick one type of dish. So if we pick the two type of dish, then the answer will be we can pick dish in the second index. We can pick in the dish in the fourth index because we can't pick dish in the third index, it is adjacent to second index. So the answer will be 2. So among 1 and 2 type, the answer will be 1, because 1 has, by choosing 1 we can pick maximum number of dishes, which is 4. So the answer will be 1 here. Same for these examples. If we pick 1 in the first position and the third position, then we can pick 2 number of dishes. If we pick second type of dish, then the answer will also will be 2, because we can't pick these two together. So for this case the answer can be 1 or 2 both, because both has 2 number of dishes. For this case there's only one element, one type of dish, one. So we can pick only we can pick only one here. So and here, if we pick one, then the maximum number of dishes we can pick is 2. If we choose 2, then the maximum number of dishes can we pick is 3. If we choose 3, then the maximum number of dishes 1. And if we pick 4, then we can can pick maximum number of dishes will be 1. So the answer will be 2, because by choosing 2 we can pick 3 dishes. So uh, I hope the problem statement is clear. Now we will go and write code for it. Okay, so now we will write code for our problem. I have already taken the input for the problem. In the inputs, n represent the total number of dishes in the menu, and the array ARR will represent the all the dishes, and each index of the array will represent the type of that dish. And in here inside this solve function, we will write our logic. So first we have to calculate that type of dish. By picking that, we can pick the maximum number of dish by applying the condition that no two adjacent element should be taken. So what we will do, we will calculate our answer, or we will calculate the, the picked number of dishes by each type. Okay? So for storing the chosen the number of pig dishes for each type, we will store it in a frequency array. In this frequency array you can also make an map for it, but the value of the limit of um, type is the value of type is very less. It is 1000. So we can make an array for it, where each element of this array will store the number of dishes picked by that type, or each type. Okay, so frequency I will represent the number of dishes can be picked by ith type. Now we have to calculate this array. So we will take our dishes array, we will traverse this array, and we will add the current index into, we will pick the current dish which is in the ith index, and increase that type in the frequency array. Now for the second condition, that no two adjacent elements should be picked. So we are, you can see we are picking the ith index. So we can't pick the I plus 1 index if they have the same type. So we will write the condition here, that if the current index and then the next index has the same type, then we will skip the next index, because no two adjacent elements can be taken, and we have to make sure that the array should not go to out of bound. So I plus 1 should be in the range of the array. Now we have calculated our frequency array, and now we have to find the that type which has the maximum number of dishes among all of the types. So we will traverse the whole frequency array, and we will make we will make some variable uh, outside this loop, where answer, not answer, type, where type will store the type of the uh, dish which has maximum picked dishes. So initially it is 0, and the second one will be the dishes picked for that index, which is also 0. Now we have calculated our answer for each index. We will see that if the current type has maximum number of dish, then the previously calculated dishes types, then we will update our answer. We will update our type and we will update our answer. Now our type has the that type which has maximum number of picked dishes. Okay. So if, okay, not answer, type. So for this case, answer will be 1, because you can see that if we pick one, then we can pick this one, and this one. We can't pick that one, and we can pick this one. So if we pick one type, then the total number of picked dishes will be 4. And if we pick two, then the total number of selected dishes will be 3. So among in 1 and 2, one has maximum number of dishes. Thank you. Okay, so the given problem statement is Sam is handed a rectangular piece of paper with the dimensions h into w, where h denotes height and width, w denotes width. Sam wants to fold the paper in the fewest possible moves such that its dimensions are h1 and w1, and the paper could only be folded parallel towards the edges, and the dimensions should be integers after folding. If h equals to 8 and w equals to, okay, this is an example. So what is given, that initially we have given a rectangular paper with some height and some width. We have to convert it in another height and width, h1 and w1, and in one move what we can do is we can parallelly fold the paper, or and the dimensions should be integers. Like if initially the dimension is 8 before the move, and then after applying the move we can convert it to 6, 5. Like it should be an integer, not in a double of float number. And we can only fold it parallel towards its edges. It means we can either fold it towards its height, or either convert it by its width. Okay. So the total number of moves will be the number of moves to convert h to h1 plus the number of moves needed to convert w to w1. And both conversion will follow the same logic. So we can write a separate function for it, which will convert one type of dimension to another type of dimension. Moved for dimension. So by using this function will convert a height of d, or a width of d, to the width or height of d1. So our answer will be the sum of conversion of h to h1 plus the sum of moves required to convert w to w1. Now we have to find the logic that how we will convert one type of dimension to another type of dimension, like h to h1 or w to w1. So let's suppose an example of 12. So in one fold, in one move, what will be the minimum size we can achieve by folding the paper in one move? Uh, yes, we can convert it to, we can fold the paper into half, and that will be the minimum height that we can achieve after folding the paper into one move. And till 6 we can achieve, or we can also achieve 7, we can also achieve 8, we can also achieve 9, 10 and 11. So if we have to convert some height to another height, we will half the paper, we will half the paper until we will get a height less than the required height, less than or equals to the required height. Because to convert a height to another height which is not half of it, which is just less than of it, we will need one move. Like to convert 8 to 6, 6 is not half of 8, still we need one move to convert it. So we will half the paper until we get less than height, because in one move can convert it to 4. Okay, we need one move here, so it is same as converting it to half. So what we will do initially, moves is moves are 0, and we will apply this operation until the current dimension is greater than the required dimension, we will apply this operation, we will apply moves in it. Okay, so in one move what we will do, we will convert it to half. If it is odd, then we will convert it to the floor roof value of its half. Because let's take an example. If the height is 9, then what will be the heights we can achieve? We can convert it to 7, 8, 8, 7, 6, or 5. We can't convert it to 4, and 5 is the roof value of its half. So we, if it is odd, then we can achieve the roof value of its half, which can be calculated by this. And if it is even, then we can easily half of it, and then we can return the moves. Okay, we have calculated it for height, and also we have calculated it for width, and the total answer will be sum of them. So for this case, let's calculate the answer. The answer will be 3. Again run the code. The answer will be 3, because there's one move needed to convert 8 to 6, and the two moves needed to convert 4 to 1. Why two moves? By 4 we will convert it to 2 by folding the paper into half, and then by applying one operation we will convert it to 1. So we need two operations to convert the width 4 to 1. So the total moves will be 2 plus 1, 3.